Welcome back. This is Mr. Hassan's Maths channel, and I'm now on question number 8 from this specimen paper for the Pure Mathematics paper 3. This is from the Cambridge 9709 syllabus, and here we have a question about vectors, and here we're told about this diagram OABC, which is a three-dimensional diagram. It's actually a pyramid where we can see OAB. You could say that's the base. It says O to A is 2 units long, O to B is 4 units long, O to C is also 2 units long, the edge OC is vertical, the base AOB is horizontal, and the angle AOB is 90 degrees. So there's 90 degrees here, there's 90 degrees here on the ground. Look at the base. Just make that a bit neater there. Okay, so that's the side, that's the base, sloping side. These two sides are vertical. It says unit vectors I, J, and K are parallel to OA. So I is parallel to OA, and it's a unit vector, means this is 1 unit long. From there to there is 1 unit long, and therefore this is 2 units long. So OA would be 2I, as you can see. All right, and it says J and K are parallel to OA, OB. So J is parallel to OB and K is parallel to OC. So that means OA must be 2I, OC must be 2K, and OB must be 4J. Okay, because it's 4 units long. All right. So the midpoints of A, B, and BC are M and N respectively. So these are the midpoints. So that cuts that in half, and that cuts that in half. All right. So it says express the vectors O to N and C to M in terms of I, J, and K. All right. So I'm just gonna copy this information. So O to N and O to N and C to M. Okay. So first of all, we got this is 2K from O to C, and this is 2I from O to A, and this is 4J from O to B. Now, they've told us to express the vectors from O to N and C to M. So O to N is going to be this line over here. Let me just draw it in a different color. That's O to N. And C to M is from here to here. That's C to M. Okay. To keep this out of the way, that's 4J there. Okay, all right. Now, so we got to find the vectors from O to N and C to M. Let's look at O to N first. O to N. So let's see how to get from O to N along a route that we know. I can say that O to N is like O to C plus C to N. I'm just going to do it in terms of letters first. O to C plus C to N. I know what O to C is. That's 2K. C to N, do I know what it is? No. I don't know what it is directly, but I know that C to N is the same as half of C to B. C to N is half of C to B. So I can say O to N is equal to O to C plus a half of C to B. A half of C to B. Okay, so let's work out what C to B is. I'll do that down here. So what is C to B? Okay, now C to B is if you go from C to O and then from O to B. C to O plus O to B is C to B. And so if I do C to O, that's minus 2K plus O to B, which is 4J. So you can say this is 4J minus 2K. All right. So C to B is 4J minus 2K. C to B is 4J minus 2K. Okay. So C to N is going to be half of that. So we can say O to N is going to be O to C plus, now, we can say this is going to be half of 4J minus 2K. Okay, so this is C to N here. All right. Let's say what O to C is. We know what O to C is. O to C is K. It's 2K, sorry. O to C is 2K. So 2K plus a half of 4J minus 2K. So let's just simplify this. So O to N is going to be 2K plus 2J minus 1K. So you end up with 2J plus K. That's the vector from O to N. Okay, so that's O to N. There's the answer for part A. So that's the answer for part A, the one part of part A. Okay, that's O to N. All right. Now, we want to find also the vector from C to M. So we've done O to N. That's done. Now we've got to go for C to M. Okay, so C to M. If I want to go from C to M, I can do in a number of ways. Probably the simplest way is to go from C to A and then C to M, or probably better C to B and then B to M, because we already know what C to B is. This is C to B here. So it's probably better to go C to B and then from B to M. So C to M is going to be going from C to B and then from B to M. Okay, now C to B we worked it out already. This is C to B. Okay, we just worked it out over there. So C to B is 4J minus 2K. But before I write it out in terms of IJ and K, I will just figure out what B to M is. Now B to M is a half of B to A. Why? Because M and N are midpoints, as I said. As we mentioned earlier, they're midpoints. So B to M is half of B to A. So this is going to be a half of B to A. So let's work out what B to A is. B to A. You're going to go from B to O and then from O to A. That's probably the easiest way. From B to O plus O to A. So B to O is minus 4J and O to A is plus 2J. So plus 2I, sorry, plus 2I. Minus 4J plus 2I. So we can say it's 2I minus 4J, and write it in order, 2I minus 4J. So we can say C to B, as we mentioned already, is going to be 4J minus 2K, as we worked out already. So you got 4J minus 2K plus a half of, and B to A is 2I minus 4J. 2I minus 4J. Okay, so we end up with C to M is 4J minus 2K plus I, and that's going to be minus 2J. So we end up with I, and we have plus 2J and plus 2K. Alright, so there's C to M. Okay, I plus 2J plus 2K. I plus 2J minus 2K, sorry. Be careful. Very easy to mess up here. Minus 2K. Alright. So you can even kind of like get a feeling for whether your answer is correct by doing some sort of a little tracing of the answer. I'll show you what I mean. For example, O to N is 2J plus K. So if you think about from O to N, you start from O, you go 2J, 1, 2, and then you go 1K. So it looks like it's correct. So you're going 2 along here and then 1 along, like 1K up. So just roughly looks like it takes us to the right place. And C to M is I plus 2J minus 2K. So you have 1I, and then you have plus 2J. Okay, 1, 2. So there's something wrong with my C to M. Sorry, C to M. That's not. Sorry. Okay, so that was O to M. C to M. You got minus. You got. If you think about it in terms of what we have here, if we start from C, we go minus 2K. That's right, and then you have plus I. So plus 1I and then plus 2J. It looks like it takes us exactly there. Minus 2K plus 1I plus 2J. Okay, minus 2K plus 1I plus 2J takes you exactly from C to M. Okay, so if you trace out the answer, it will give you an idea that you have done the right thing. Okay, so there's your answers to part A. Okay, now I like to write my answers also in this form for calculation purposes later on. So O to N, I'll write it in terms of column vector, so 0i plus 2j plus 1k, and C to M, we have 1i plus 2j minus 2k. The question asks you to write it in this form, and that's how you should write it as your final answer, but I'm going to use these for purposes of calculations. So now the next part of the question, let's stop there 1 second. Can I move them? Okay, so now we're told to calculate the angle between the directions of O to N and C to M. Now we just found out what those vectors are. So the angle between the directions of O to N and C to M. So we have O to N and we have C to M. Okay, the angle between them, okay, is going to be this angle over here. Let's call it theta. That's the angle between O to N and C to M. Now the formula for finding the angle between two vectors is the cosine of the angle is equal to the dot product of those two vectors, okay, divided by the product of their magnitudes. Okay, so let's call this vector A and let's call this vector B. All right, so we can say that the magnitude of the two vectors, although let's find the dot product. We can say A dot B will therefore be these two vectors multiplied. Now the dot product of two vectors is found. It's really easy, and there's some reasoning behind it which I'm not going to go through now, but it's very simple. You just multiply the I components together, so you have 0 times 1 plus, and then the j components together, which is 2 times 2 plus the k components together, 1 times minus 2. So that's going to give you 0 plus 4 minus 2, which is going to give you 2. That's the dot product. And then we need to find the magnitude of each of those vectors. So the magnitude of A is going to be the magnitude of this vector, which is basically, using Pythagoras, you got 0 squared plus 2 squared plus 1 squared, which gives you the square root of 5. 4 plus 1, that's 5. Okay, and the magnitude of vector B is going to be the square root of 1 squared plus 2 squared plus 2 squared. We don't have to worry about the minus signs because they're going to get squared anyway. That's going to be 4 plus 4, which is 8, plus 1, which is 9, the square root of 9, which is going to give you the exact value of 3. Okay, so now we want to find the angle between the two vectors. So as I said, the cosine of the angle is going to be the dot product, which is 2 over the product of the magnitude, which is 3 root 5. And therefore we can say theta is equal to inverse cosine of 2 over 3 root 5. So therefore theta is equal to, let's take the calculator, we have inverse cosine in degree mode, that's good, of 2 divided by 3 times root of 5, and there we have our answer, 72.653, 72.653 degrees. So to 1 decimal place, they didn't tell us what to do it, so you do 1 decimal place, 72.7 degrees, 72.7 degrees. Alright, so there's the angle between those two vectors, okay, and that's the angle when they are tail to tail. Okay, that's how you work it out. If they say, if the angle, for example, came out as obtuse, and the question said find the acute angle between them, then you just do 180 minus the angle, if that was the case. Sometimes they say find the acute angle between them, and the angle you get might be obtuse. Okay, in that case you do 180 minus the angle that you found, and that will give you the acute angle between them. In this case, they didn't specify anything, we just write down the angle we find, which is 72.7 degrees. Okay, then it says show that the length of the perpendicular from M to ON is 3/5 root 5. So if we think about from M to ON, let's draw the line ON first. From M to ON would be a line which meets ON at right angles. Okay, so this is that's a right angle. We want to find the length here, x. Okay, now what we've already found might help us. Let's see if it does. Let's see if that's the first thing you should always do. Check if this is 72.7 degrees. We want to show that this is 3/5 root 5. Okay, we don't have this length. We don't have that length. So it doesn't look like we can use this angle that we found in this question to find this length x, because we need to have these two lengths, either of those two lengths. If I know this length from there to there, or this length from there to there, then I would be able to proceed, okay, to use that angle. But it doesn't look like we can use that angle, to be honest. So let's, okay, that's always the first thing you should do. Always check to see, can you find something from the previous answer. Sometimes they build up. Normally they do build up. In this case, it doesn't look like it. So let's just make a right angle triangle from here, because these are things that we can find the lengths of. I know that that's a right angle, okay, because it has to be a right angle, because they said we have to find that length, which is from M to ON at right angles. So that's definitely a right angle. Now, if I can find, for example, this angle over here. If I can find this angle over here, let me call it angle alpha. If I can find this angle over here, then I will be able to find that length, because I can find the length OM. I can find the length OM quite easily, all right? Because we know what the vector O to M is. We already worked it out. You know, O to M is basically O to B plus B to M, or O to A plus A to M. We can work that out. So therefore, we can find the length of O to M very easily. Okay, and if I also know this angle over here, then I can work out what x is in this right angle triangle. So I'm going to go by, all right, how do we find the angle over here? Well, what I can do is, if you think about it, I'm gonna make it a different color. Actually, make it a red color. So let me join O to N and O to M and M to N. Now this triangle over here, I can find all three of these lengths. I can find O to M, I can find O to N, which I already know. I know the length O to N, we just worked it out. That's going to be root 5. I know this is root 5. Okay, O to M I can work it out. M to N I can also work it out. Okay, M to N in fact is going to be half of A to C. How do we know that? Because M is the midpoint of this line, N is the midpoint of that line, so M to N is going to be half of A to C, because it's going to be parallel to A to C and half its length. That's one of the proofs that we should know, okay, from our, these two are similar triangles. Okay, these two are similar triangles. So we can find M to N. So I know O to N is root 5. We worked that out in the previous question. And O to M, so the magnitude of O to M is root 5. Now O to M, I can calculate its length. It's like O to A plus A to M. O to A plus A to M. So O to A is 2i. This is 2i. Plus A to M. Now A to M, I think we did some of the groundwork for A to M before. Let's have a look. We found B to A. Okay, so B to A is 2i minus 4j. Okay, so that means if I write that down, 2i minus 4j is BA. So we can work out, we can say that BA is 2i minus 4j. 2i minus 4j. Now if I want to find A to M, that's like B to A, half of B to A. Okay, or A to M is the opposite of it. A is going this way. Okay, so we can say that A to B is minus 2i plus 4j. So therefore A to M is a half of minus 2i plus 4j. So A to M is going to be, one second, let me write this properly. Shouldn't be so messy. So as we said, b to a was, let's make sure, 2i minus 4j. 2i minus 4j. 2i minus 4j. That means a to b is going to be minus 2i plus 4j. So a to m is a half of that. It's going to be a half of minus 2i plus 4j, which is going to be minus I plus 2j. So 2i, you can say plus 2j minus I, plus 2j minus I. So you're going to have I plus 2j, I plus 2j. O to m is I plus 2j. Okay, so that we found O to m. So therefore the magnitude of O to m is going to be the square root of 1 squared plus 2 squared, which is the square root of 5. So this, in fact, this is an isosceles triangle. This is root 5 as well. Okay, and we can find what m to n is. As I said, m to n is a half of a to c. We can even find it directly. We can say it's like m to b plus b to n, for example. Okay, but I think this is probably easier. A to c is minus 2i plus 2k, minus 2i plus 2k. That's a to c. So m to n is minus I plus k. That's m to n. So we can say therefore the magnitude of m to n is going to be the square root of 1 plus 1. 1 squared plus 1 squared, 1 plus 1, which is root 2. So this length from m to n is root 2. Let's move the x out of the way. Okay, so that's root 2. So now we have a triangle where we know all three sides. We have a triangle that looks something like this, where we have the length of all three sides. Those two are equal to each other. Okay, so this is root 5, sorry, and this is root 5, and this is root 2. And we want to find this angle alpha. This is our O, this is our M, and this is our N. So we can say that the angle alpha we can find using the cosine rule. We can say cosine of alpha is equal to, now remember, it's b squared plus c squared. So it's 5 plus 5 minus a squared minus 2. So this squared plus this squared minus that squared over 2bc. So it's 2 times root 5 times root 5. So that's going to give you 10 minus 2, which is 8, over 2 times 5, which is 10. So we can say the cosine of alpha is equal to 4/5. We don't actually have to find what alpha is. We want things in exact form as the answer suggests. Show that it's 3 over 5 root 5. That's going to be the length of O to n. But once we've found that, we can now use this right angle triangle. I now know what this angle is here. I know the cosine of this angle. So we know that the cosine of alpha is equal to 4 over 5, which means that the sine of alpha is 3/5. How do we know that? Because if you have a right angle triangle and you know that this is alpha and the cosine of the angle is 4 over 5, then this side must be 3 by Pythagoras. So the sine of the angle must be 3/5. The tan of the angle was 3/4. So we know the sine of the angle is 3/5. So now I can use the other triangle OM, and let's call this P. This point P. MP is X. So we can use this right angle triangle now. I'm just going to use this space over here. We now have a right angle triangle. It's not the same as that triangle. It's a right angle triangle now. And we have, I don't know why it's doing that. This is the right angle. We call that P. This is M. This is O. Okay, this angle is alpha, which we have worked out the sine and cosine of. Okay, we can say therefore the sine of alpha is equal to 3/5, as we just showed. Okay, we know that this length is root 5. We don't know these two lengths because this is up to here, point P is over there somewhere. But we know that this length is root 2. We know that, sorry, no, we don't know that length either. We have to find that length. MP. Okay, the length we're finding is this length, which is we're called x. So we can use the fact that this is a right angle triangle, this is the opposite, this is the hypotenuse, so we can say the sine of alpha equals the opposite, which is x, over the hypotenuse, which is root 5. And we worked out the sine of alpha is 3/5, so 3/5 equals x over root 5. Therefore, x equals 3/5 times root 5. And that's exactly what we had to show. Okay, so there is our answer to this question. Right, so it's actually quite an involved question, 4 marks, but there's quite a lot of thinking involved in this question. And at first sight, the solution to the previous question doesn't seem to be something that would help us. There might be a way to work out where it does help us, but I couldn't see it, because if you consider this triangle that's formed M, what we call P, and this point here, we only know the angle, we don't know anything else. You know, we would know all 3 angles in the triangle, because that would be a right angle, but we wouldn't be able to work out any of the 3 lengths as far as I can see easily. It's possible that we could have done it another way, using some sort of scaling of the vectors, but I think this would probably be the easier way, where we worked out what this angle is using the cosine rule, and then use the fact in this right angle triangle, we know this angle, we know this length, and we can work out what x is. So there's the answer to the question. Other questions from this particular paper can be found in the playlist, which will appear in the top right of the screen at the end of the video. Other questions from the topic of vectors from P3 of Edexcel, of Cambridge, can be found in the playlist over here. P4 vectors questions from Edexcel, which are quite similar. You can find the playlist for those over here in this link over here. You can subscribe to the channel by clicking on this link on the top. Thank you for watching, and see you soon.